Hey guys, this is lesson 6, exercise 1J, solving simultaneous linear equations algebraically. Bit of a long title, yes. Each word though has its importance. Solving, so we're looking for a certain solution. Simultaneous mean two going, or sometimes more than two, but two going at the same time. Linear, because we're talking about straight lines. Equations, anything that has an equal sign in it. And algebraically, just using tactics through the algebra world to try to solve this here. Right now, what we're actually trying to do isn't gonna necessarily make a bit of sense, especially if we just jump straight into the example and we look at this little mind map. So to give you a good intuitive feel of what's going on, the best way I like to think of it is we're used to equations, okay? And say we have something like this: x plus 3 is equal to 5. So some number, when 3 is added onto it, will give us an answer 5. We know that this answer to this equation has to be 2. This is the only solution that works for it. There's no other number that works, okay? And I can give you another easy example. X minus 8 will give me 10. We only can have an answer, one answer, in this case. X has to equal 18. Okay, these are the type of equations that we had from our previous examples. Really simple to try to find them out. We did get complicated ones, but this had to do when there were only one variable involved. We're now looking at equations where there are two variables involved, or two letters, but not only that, there are two of these equations going on. So a good intuitive feel how this works. Let's say I get this equation, okay? X plus y is equal to 10. And you're thinking, okay, this doesn't make sense because we don't know what y is. And because we don't know what y is, there's no way of me knowing what I can substitute in for x. But what this equation is actually saying is you can give me any two numbers, okay? And these two numbers can be the same. You can give me any two numbers and I can tell you what two numbers, when added together, can give me 10. And then you're thinking, oh, okay, let's try x equals 1 and y equals 9. Well, that works, doesn't it? Because when I plug 1 and 9 into this equation here, into the left-hand side specifically, it will give me the answer 10. Okay, so this is what we call a pair. This is a pair of solutions. And we don't usually write it like this. We generally write it like this. Okay, that's right. 1, 9. Because traditionally speaking, we always put the first number as the x value and the second value as the y value. So 1, 9, this yields for x plus y is equal to 10. But then we can also do 2 and 8, okay? Or 2, 8. That's also a pair of solutions. Heck, we can do 3, 7, 4, 6, 5, 5. We can even swap them around. 6, 4, 7, 3, 8, 2, 1, 9. Heck, we can do 0, 10. But it doesn't even have to work with whole numbers. We can do decimal numbers if we want. We can do x equals 5.5 and y equals 4.5. We can do x equals 5.0001 and x equals 4.9999. In fact, there are an infinite amount of solutions. infinite solutions. Okay, so many solutions, decimals, and also fractions as well. Okay, and whole numbers, negative numbers even. You can have x equals -1 and y equals 11. Okay, that can work. So seems a bit kind of redundant if we're given just this one equation. But then let's say, okay, let's say that I'm going to introduce another formula, and I said, all right, x minus y, this right here has to equal 12. Okay, so we've got right here what is called a pair of equations. Right? So I can take any number, any set, any pair from here, and I can put it into this equation, provided that those same two numbers that I put into here also works when I find the difference between the two, and my answer gives me 12. Then you think, this is going to be a bit tricky, because right now there's only one pair of numbers where this works. Okay, only one pair. Because I can't do 1 and 9. If I do 1 and 9, yes, that will give me 10. But if I do 1, take away 9, that's going to give me -8, which isn't 12. So this answer right here, that doesn't work. Okay, so what two pairs of numbers can work for this? Okay, have a think about that, see what you get. The answer to this actual solution is a bit of a tricky one because it does involve negative numbers. But the answer for this one is x is equal to 11 and y is equal to -1. This is the only pair of solutions, solution, not plural, that will work for this. Because when I substitute 11 into here and -1 into here, this will give me 11 plus -1. When a plus and a minus are put together, it will give me a negative. So 11 take away 1, give me 10, so that works. And 11 minus -1, when two minuses are put together, this will give me a positive. So 11 plus 1 will give me 12. So this pair of solution is the only pair that will work for this set of equations. And this is a process. We are solving simultaneous, this is what simultaneous, these two equations, linear equations, algebraically. Now, I have not shown you the algebraic part. This is what the next part is, okay? And you'll see this in the next video. But what I wanted to show you is what is exactly going on. What are we doing with these equations? And how do we, what is it that we're trying to do? How to solve it? And how two-lettered or two variable equations actually work. Now, these equations, this is just a very simple example, okay? You'll get complicated examples where you might have something that looks like this. Y is equal to x plus 5. This will be considered as one of your equations. And then another one is 2y take away 5x is equal to 19. Okay, now we're not going to solve for this, but all we are doing is I can give an x value, substitute that x value into here, and get a corresponding y value. Okay, with those sets of x and y values, they also must be able to be substituted into this equation here. Whatever numbers we end up getting, those same numbers have to be substituted here to give me the answer 19. And your mission is to try to find what this x and y values are. Okay, the process of how to solve it is a bit time consuming and can be very tricky at first, but it does take a bit of practice. So the next video will show you how to solve this. I will see you in the next video.